AlgebRuss. This is a video to review the concepts on solving the greatest common factor or the GCF and the least common multiple or LCM of a group of numbers. These concepts are so important and has so many applications in mathematics that every student should master. But as we proceed, let's quickly recall a topic called prime factorization. Remember that prime factorization is finding all primes that when multiplied together will make the original number. Also recall that a prime number is a number that is only divisible by 1 and by itself. Let's review prime numbers by listing some of these numbers. On this part, we'll write the composite numbers. Let's start from the smallest. Note that 1 is neither prime nor composite. So the smallest prime is 2. It's divisible by 1 and by itself only. Then 3 is prime, since it's divisible by 1 and itself only. 4, aside from divisible by 1 and itself, is also divisible by 2, so it's composite. Using those criteria, we continue the list of numbers. So 5 is prime, 6 is not, 7 is prime, 8 is composite, 9 is not since it's divisible by 3, 10 is composite, 11 is prime, and so on. Now, going back to prime factorization, let's say we're asked to get all the prime factors of 24. There are a number of ways we were taught to do this. One is using a factor tree, wherein we just write two numbers that multiply to the number and continue branching out until we end in a prime number. Let's quickly try that. 24 we know is 3 times 8. 3 is prime, so let me encircle that since it's the end of the branch. Looking at 8, we know it's 2 times 4. Since 2 is prime, let's encircle it. We are now left with 4, which is 2 times 2, which are also prime numbers. So, looking at our tree, the prime factors of 24 are 3, 2, 2, and 2. If we multiply them together, the product is 24. Another method is called continuous division. Let's do this by drawing two columns, like so, and putting 24 here. Let's think of a prime number that exactly divides 24. Since we have a list here on top, let me use it as a guide. It's best to start checking the divisibility from the smallest prime, which is 2. We know 24 is divisible by 2, so write 2 here. Dividing 24 by 2, it's 12. Write it here. We check divisibility again. 12 is divisible by 2. Therefore, 6. 6 is divisible by 2. Therefore, 3. Which is of course now a prime number. Hence, looking at these parts of the table, the prime factors of 24 are 2, 2, 2, and 3, which is exactly the same as the other method. But what we really like to recall is how to do continuous division but writing the factors in a row instead of writing in columns like in this part. Okay, let's start from 24 here. Then using again our list of prime factors on top, we know 24 is divisible by 2. Write 2 here. 24 divided by 2 is 12, but we don't need to write 12. Just remember the quotient 12. 12 we know is divisible by 2. Write 2 again here. 12 divided by 2 is 6, but we don't need to write the quotient 6. 6 is divisible by 2, so write 2 again. 6 divided by 2 is 3. Write 3 down since it's a prime. Thus, we end the list of prime factors of 24. Take note that the prime factors we got are consistent with the answers we got from the other two methods. Also, take note that the arrangement of these numbers doesn't matter Because multiplication is commutative, they're all equal to 24. Now, let's recall applying prime factorization to get the greatest common factor of numbers. I know some can do this mentally, but let's do this because this skill will be very much needed in future topics in algebra. Let's look at this example. We're looking for the GCF of 18, 45, and 63. Let's write the numbers on the right side like so. And then, list all their prime factors. Let's start with 18. 18 is divisible by 2, so let's write 2 here. 18 divided by 2 is 9. 9 is not divisible by 2. However, 9 is divisible by 3. So we write 3 here. 9 divided by 3 is 3, which is already prime. Therefore, write 3. So for 18, we have the factors 2, 3, and 3. Now, take note that when using the prime factorization technique to get the GCF, aside from writing the prime factors, we should align common prime factors. So let's apply that. And this time, let's break 45 into primes. 45 is not divisible by 2. However, it's divisible by 3. So let's write 3 here. But as we said, let's align common prime factors, so put 3 here. Align to the 3 on the upper row. 45 divided by 3 is 15. 15 is divisible by 3. Again, write 3 here, aligned with the 3 on top. 15 divided by 3 is 5, which is already prime. Therefore, write 5, but on a separate column this time. So, for 45, we have the factors 3, 3, and 5. Lastly, let's quickly break 63 into primes. 63 divided by 3 is 21. 21 is divisible by 3. So write 3 here. 21 divided by 3 is 7, which is already prime. So write 7. So here are all the prime factors of the numbers 18, 45, and 63. Now, the next step is to bring down all complete columns of factors. So, we have this column and this one. Bring them down so we have 3 and 3. Multiplying them, the GCF therefore is 3 times 3 or equal to 9. Of course, as we said earlier, some of you can do this mentally confidently. So you can skip prime factorization and write 9 immediately. But again, knowing this process will be valuable in the long run. So, let's have some exercises. And they're asked to get the GCF of the following. Yup, using prime factorization so you can practice. You can pause this video now and work on them. Don't worry, the answers will be shown in a while. Kaya yan, go! Here are the answers so you can check. Now, let us apply prime factorization to solving the least common multiple of numbers. Let's use the same examples that we have taken earlier. But instead of getting the GCF of 18, 45, and 63, let us solve their least common multiple this time. On the left here is how we computed for the GCF. And now on the right, we solve for the LCM. We do this so we can see their similarities and differences. We still use prime factorization though, and therefore simply copy the prime factors from the left. Again, making sure to align common prime factors. Let's do that quickly. This time, however, instead of bringing down the complete columns only, we now bring down all columns. So we bring down 2, 3, 3, 5, and 7. Multiplying these factors, we have 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is 90. And finally, 90 times 7 is 630. So the LCM is 630. Now, if you cannot do that mentally, you can group numbers any way you want. So let me write again these numbers that we brought down. 2, 3, 3, 5, and 7. 2 times 3 times 3 is 18. 5 times 7 is 35. Multiplying these, 18 and 35, we have 630. Same as what we got above. Now, another way of getting the LCM is listing all multiples of each number. Let us try and quickly do that. We get the same answer. However, as you can see, it would be a very tedious task, most especially in getting the LCM of 3 or more numbers. Prime factorization is usually a faster way of getting the LCM. Just remember, GCF bring down the complete columns only. LCM bring down all columns. If ever that is confusing for you, here's a tip. That is, if you're great at memorizing, simply get both values every time. The smaller value is the greatest common factor, while the bigger value is the least common multiple. It's counterintuitive, I know, but hey, that is one way to remember. Now, let's have some more exercises. Get the GCF and the LCM of the following numbers. Yup, again using prime factorization, so you can practice using this important concept. You can pause this video now and work on them. Don't worry, the answers will be shown in a while. Kaya yan! Go! Here are the answers so you can check. I hope you learned a lot. Please don't forget to like and subscribe. Happy solving!